Greetings and welcome to a brand new series based on the idea that I had in a previous video, Are Two Heads Better Than One, which was actually referring to these cheap solar garden lights that you can buy at the dollar store. And what I wanted to do in this particular video was to go through the anatomy of one of these garden lights to start with, and then in future videos I want to go into some of the modifications that you can do and how you can do them. But in order to do those modifications, you really need to understand what it is that we're working with. So let's take a look at this garden light. And this is an experimental setup for me, trying to get used to doing things on the table. I'm used to doing my garden videos. Really what we're interested in is this piece here. And let me see if I can find my screwdriver. I probably should have had that set up to begin with. Hang on a second, I'll go get it. Okay, I've got the screwdriver. Here it is. And in order to understand this, we're going to have to open it up. And in order to open it up, there are two screws, one here and one here. Now, not all of these solar garden lights are the same, but this is a very typical one that you might find, and you will probably have something similar to this. So I'm going to go ahead and reach over the camera and unscrew these two screws. Let me get that one out. Let me get that one out. And actually, before I take it apart completely, since I said this is an anatomy lesson here, what we need to understand is what we have on the outside. So what we have on the outside, that is the solar cell, that glassy sort of thing with the lines running through it. Hopefully you can see the lines. What that does is take sunlight and turn it into power. There are much bigger versions of this which you will now find on people's rooftops. If you live in a big city, you might even see some installations like in a parking lot, where they put up these what looks like shelters for people to park under, but they're actually solar panels. And there are even some of them here in LA, some larger installations where you just see a whole field of them. But this is just a really small, like 1¼ inch by 1½ inch, something like that. And it provides about 5 to 6 volts in full sunlight. Now, full disclosure, where I am, my little garden that I have here only gets shade, so I don't get the full benefit of that, and that is the inspiration for me doing some of these solar light projects, is trying to figure out how to maximize the efficiency of these things. On the bottom here, we have the LED light, which in this particular case you can see is actually bent over, but if you're careful, you can just bend it back a little bit. Not a big deal. And then there is a power switch. And on the circuitry inside, I can tell you these switches are very cheaply made. So sometimes you may turn it on and then you find that it just kind of shuts itself off. It's not a defect in the circuit, it's a defect in the switch. These things are really cheap. So I'm going to go ahead and turn this on and hope it doesn't completely swamp everything out. And there you can see the light is now on. Now the reason why the light is on is because it thinks that there's no sunlight. If I were to turn this over, let me see if I can do this in a way that you can see it. If I turn it over, once it gets some sunlight, I'm going to let go. You'll see the overhead lights are now being treated as if they were sun. And the solar cell itself, whoops, let's see if we can do it this way. Let me put this on the table, and if I cover up the solar cell, you'll see that it turns on. If I uncover the solar cell, it turns off. Now, if we want to crack this thing open, the first thing I'm going to do, just so it doesn't swamp out the camera, is I'm going to go ahead and turn it off. Some of these will also have like a little pull tab that you can pull, and what that does is engage the battery that's inside. Now let's crack this thing open. Well, not crack, but I'm going to open it up, and I found that the simplest sort of way, you could try and get your fingernails around the outside, but I just use a screwdriver. These things are only $1, so it really isn't that critical. And I'm going to open it up, and you can see the circuitry inside, and you can see two little wires coming from that solar cell. Remember, this is the solar cell. You see the two wires coming and going to that circuit board. You can also see a battery in here, and I need to tell you something about these batteries. Let me see if I can actually pull this off. These batteries, I have found out through testing, are generally overstated in terms of their capacity. If you go shopping for rechargeable batteries, and this is a rechargeable battery, nickel cadmium, if I'm not mistaken, because most of the yellow batteries in these things are nickel cadmium, and the green ones tend to be nickel metal hydride. But if you go shopping for rechargeable batteries, you'll see that one of the things stated is the milliamp hours. And on this one, let me, if I can, there it is, and I don't know if that's going to come into focus or not. As you can see, it says it's 300 milliamp hours. I'll bet you it's not. If I were to actually run a test on this, now this is brand new, I have not taken this apart before. When I took it apart and the label came off, that was the first time I ever worked with this one. And in my testing, I'm finding that these batteries are typically about 60 milliamp hours. If you get really lucky, you might get 100 out of them, but certainly not the 300 that they're claiming. Now, the reason why that's important is because this little LED that's on here, whoops, getting away from me, this little LED that's on here, and the way the circuitry is designed, typically consumes about 2 milliamp hours. Now, if your capacity is 60 milliamp hours and the light is consuming 2 milliamp hours, that means you have a total of about 30 hours of runtime on the for the light. The problem with that is if the battery doesn't get fully recharged during the day, then after a few days, your light is not going to turn on anymore. And so that's why I tend to, one of the very first modifications that you can make on this, and it's very simple, once you get those two screws out and you take this, take the bottom piece off and get to that circuit board, is you can take the battery out, you can put a better battery in there. The better battery, you still have the same problem. If it's not charging up enough during the day to cover the amount of power that's consumed at night, then it doesn't matter how big a battery you put in there. So one of the key things, one of the key modifications you want to make to a circuit like this is to find the balance between how much charge you're getting during the day and how much charge you're using at night. That, or you just accept the fact that you're going to have to pull the battery out, recharge it separately, and put it back in every so many days. Now let me put the battery back to the side here, and let's take a look at this circuit. Now I'm going to try and move this around a bit so that I can get it steady, because it's pushing up against those wires. If you do it right, you just about get this thing propped into itself. Well, that's not exactly working, but let's take a look. This is a very simple little circuit board, and the reason it's so simple is because there is a chip here that has 4 pins on it, and that does a lot of the intelligent work for the circuit, leaving only a few components required. Now this is the back side of the circuit board. If we want to actually see the circuit, there's another screw here. Now sometimes it's not a screw, sometimes it's a it's basically heat welded. It's a little plastic post that this is stuck on right where that hole is, and they heat up the end of it so it's like a rivet, and it holds the board on, and the only way to get the board off is to actually cut that end. Once you cut that end, you're not going to be able to secure the board back. But most solar garden lights are not going to be sitting in an application where they're moving around a lot, so I don't think that's a big deal. You just kind of stick it back on the post. Now I'm going to try and pry this off, and there it is. And now here we've got it off, and now we can see the front side of the circuit board, and you can see you've got the two wires going out to the battery, you've got 2 wires going to the solar cell. Really, that's almost the whole circuit right there. Here's that little chip I was talking about. Here's that switch that I told you is not the greatest. Now you got to remember, they're using as cheap components as they possibly can because they're trying to produce these things for less than $1 so they can sell them for $1 and make a profit. Here is the LED light, okay, and that is what lights up. Now actually I don't have a battery in here right now. I was going to flip the switch and show you, but let's just sort of go through the rest of the anatomy of this circuit. So you have really 2 power sources. You have the solar cell on this side, you have the battery on this side. During the day, the solar cell runs through this circuit and charges the battery. At night, the solar cell actually detects the fact that there's not enough light, and it switches the circuit so that it now uses the battery to power the light. The only other component on here, aside from the switch, is this little thing here that, if you know a little bit about electronics, looks like a resistor. It's not a resistor. It's actually an inductor. It's in the same sort of packaging, except that it has, and I don't know if this is going to come through so well, a green background. And that green background makes it really hard to read the little color bands on here. And those color bands are what tell you what the value of this particular inductor is. Now let me see if I wonder if I can zoom in, get you a closer look. And pardon my hands, my big fat hands now. Let me see if I can just turn this in such a way that you can see it. And let me see if I can focus. Oh, there we go. Let me go in a little closer. And you can see that if you don't have just the right kind of lighting, you're not really going to be able to read those bands too well. Let me see. I'm going to pick this up and try and take a look at it. Let me get my reading glasses and see if I can read it. So for those of you that know about color codes, this looks like red, black, black, or maybe red, black, brown. Red, black, brown would be 2, 0, and 1 more 0. So that's 200. So it's a 200 millihenry inductor. Okay? And that is actually a fairly high value, which means that it's going to consume a fairly low amount of energy. That is what controls how much energy is going to that little LED light. So if you wanted to change the brightness of the light, if you wanted to make it brighter, you would want to take that inductor and make the value lower. I've dropped it as low as I think 15 millihenries and got, or maybe it was 40 millihenries and I got 15 milliamps going out to the light. But in that particular experiment, what I found out was that after a couple of nights, that light didn't want to light up anymore. It drained the battery. You need to find that happy medium that allows it to be as bright as it can be while still being able to recharge during the day. So that's basically the anatomy of one of these lights. And the other thing I wanted to show you real quick was I have a test rig that I built for doing my experiments. Let me bring that into view. Oop, let me zoom back out for you. And this is my test rig.